Dear students, this is the discussions we have done in the last lecture, that is from data to features, right? So we have discussed about interactive group discussions. Now in that we have covered so many things, that is like how to make data, and we can make into the feature selections, right? Data to feature selections, and we have come across different types of discussions on this. Now today we'll discuss about the next important part, which helps to make our data sciences process, that is data to features. Now the very important is when we are representing the different kinds of data into different format. That's important. Now in this particular unit and this particular discussions, you will find different types of problems, different types of data which can be represented into different way, and which helps to represent data into features, right? And it is very important for our data mining, designing the patterns, right? And we have to take different kinds of decisions finally. And when we are, especially when we are going for data sciences and the process of data sciences, it is very important how to make our data into feature based. So that features will help you to take proper designing the patterns. These particular features will help you to analyze properly the situations or case, or this particular patterns also features also helps you to design different kinds of patterns. Okay, so now in this particular discussions we will have a representing the problems with metrics. Now here the part is we have to collect the data and we have to represent in their different format, which can be effective manner to handle data and further process. Okay, for further process we can make this data easily, representing this data into further process. Now tabulations, or we call it matrix format, right? So we can represent our data. I have given a very simple and a very easy methods. I have put here. You can see here how to represent the matrix, the data into matrix format. So when you are talking about matrix, that means you might have come across different types of matrix, like 2 into 2 matrix, right? N into M matrix format. You have rows and columns you can put, and normally we use a different tabular format. It is a systematic and a logical arrangement of a classified data into rows and columns, that is tabulations. So now we can see here, what sports do you play? Now in this particular questions, you can find out easily the different types of information, or the information or data you can get through different features based. Now here is features, we can say sports. It's a one kind of features. You have a different kinds of value or data about this. You have a people, number of peoples there, right? So now we can have a different kinds of values. Okay. So now here you can find out the original data, different categorical data, or the data which can be classified into different manner can be represented into tabular format, 2 columns, and we have a number of rows we have, right? It is very easy to represent. You can see different types of sports and number of peoples. So what sports do you play? That means these are the players or these people they used to play, and it depends on a different interest they have the score here. Now 101, 45, 54, 22, 68. These are the frequencies, we call it in a statistical manner, right? So number of players, or number of persons, or number of people they are interested for a particular sports, right? So now what is exactly the importance of this metric format? Why we need to represent this particular situations into matrix format, or this particular information into matrix format? The significance of this matrix or tabular format is, first one, simplify the complex data. Whenever you have a complex data, you can represent into a systematical manner rows and columns, and it will be very convenient to visualize, convenient to access, convenient to fetch, right? So because it is represented into rows and column format, you can see also in this particular height, and you have a frequency. Okay, so now depends on different heights of the persons, you have a number of persons you will have. It's a kind of a range. Suppose you have a 56.0 to 57.0 inches. Okay, that's the height. So number of people you can have 10, right? Similarly, 58 to 59, we have a range based here frequency, you can see, right? Group values we have. Now the second most is unnecessary details and repetitions of data avoided in tabular formats. So easily we can find out which data is repeated, or it can be grouped into a particular group, right? So now this is how we can easily find in the tabular format. If you put in a normal manner, okay, so you may not find which data is repeating or which data is unnecessarily creating disturbances in this particular information chart. So now if you are representing into a tabular format, easily you can find out the you handle the different kinds of situations, right? Then it facilitates the comparison. Now easily you can compare, easily you can find out comparison, correlate, right? Easily, because it is column and rows format, or it is having a matrix format. Easily you can find out, easily you can distinguish, easily you can find out the relations among that. It gives identity to data. So sometimes to explain properly, so you can properly explain the data, you can properly identify the data. That means you can fetch, you can indicate the data easily, which rows, which column, which coordinate, you can find out easily. So that's the way the significance of your what you call tabular format it is. Reveals the patterns with figures with cannot be. So when we are using different kinds of patterns also, you can easily figure out. Now in this particular sense, you can have data, okay, and you can narrate it in a proper way, because it has been stated in a tabular format, you can find out easily. I'll show you one another examples in the next slides. You can see here how we can have different kinds of facilities of this tabular format. You can see here, just a minute, it is working. Yes, you can see here. Now, in this particular tabular format, you can see we are representing in the tabular format. First, you can see a simple table, data relating to only one characteristics. So now here you can see the characteristics. You can have gender, right? So depends on the gender, you can divide into boys and girls and the number of students you have. Similarly, we can make it is easy to arrange the data. It is easy to identify the data. If I'll ask how many boys are there, easily you can say 9. If I'll say number of girls, how many number of girls are there? 29. But if we'll keep all the records in a different manner, scattered manner, so it takes time to count how many students are there. Now in this particular things, we are dividing the data into one characteristics or attributes, that is, or features, that is based on the gender. Now next you can find out here two characteristics we are representing. See how the complexity can be, how the complex data can be represented into a simple manner using matrix format. Now if you will see number of values, number of records in a different type of attributes or characteristics, so it gives you confusion. Now in this particular format, see, though we have a two characteristics, but we don't have a confusion. Immediately you can find out the values. See boys and girls, then we can have another. You can see the red color, right? We are taking the characteristics of gender and food habits, right? What type of foods they prefer, right? Boys, out of nine, you can compare it easily. As I told in the previous, you can compare, you can take a few decisions also immediately. So now boys, that is 9 boys, they are vegetarian, and and out of total 9 boys, right? We have a 2 vegetarians and 7 non-vegetarians. So this is how we can derive the different kind of some kind of small analysis or some kind of some decisions we can take easily. Now this is a particular two characteristics data we can represent it. This is rows and columns we have, and we have represented this way. So now in this particular format, you can find out the boys and girls with respect to vegetarian and non-vegetarian. We can represent into the matrix format. Now come to this part. Three characteristics we have. So now in this three characteristics, you will find again the data is more complex. So now from the one characteristics, then the second characteristics, right? So then we are moving to third characteristics. That time you will have a complex data. The complexity of data will be having increased one step ahead, second step, third step. You will have a number of a complexity here more once the characteristics or attributes is enhancing or it is increasing, right? So here we are taking different kind of three types of characteristics here. You see here. So it is a two matrix format, that is rows and columns we are representing, but in a different characteristics we are taking, right? We call it a dimensions. We have sometimes in our data mining concept we have a dimensionality, right? So we can put gender, we have at the beginning. So one characteristics or one attribute, or we call it one features, we have boys and girls, that is gender. Then food habits at the second time, we have a food habits like vegetarian, non-vegetarian. Again, we can divide it vegetarian into the age factors. So now age below 20 years, age 20 and above years. This is under the category of vegetarian. Similarly, non-vegetarian will have this category. So below 20 years or 20 or above years. So you can find out. See here in this three different kind of table, you will find different types of information. You can derive it differently. You can find out different types of informations by collectively analyzing this matrix data, right? So now see here, as a first, it is only one characteristics, and we are finding number of students we can find out. The second, we have a two categories like food habits. Okay, on boys, how many vegetarians, non-vegetarian? On girls, vegetarians and non-vegetarians. Similarly, in this particular case, you can find out another dimensions, another attributes, that is age factors we have. So now in this gender, okay, you can see boys below 20, vegetarian is 0. That means what happens here? You can derive the, that's exactly the necessity or significance or importance of the data representing in a different format. So if we are talking about matrix, how important you can here imagine. So now a simple matrix format data can give you different kinds of information which cannot be expected, right? So I can show you this. I didn't mention here, but I am expressing, see here. Now I can say none of the students, those who are below 20, they never go for vegetarians. See here, you can see 0. So now the students, those who are less than 20 years, they are they are all vegetarians. That means those who are below 20, they need every type of food habits, right? That's why they are categories in the different categories you will have, right? So now here the point is we can take a different types of decisions, right? Again, non-vegetarian, if you'll see age below 20, non-vegetarian 1 out of 9 students. Now you can see after 20 years, okay, food habits can be determined. This is a simple thing. See here, the quantity is 0. The quantity here 2 and the quantity here is 1. Now here the problem is to predict the food habits. We cannot implement into the small children like below 20 years, because they may prefer, they may not prefer, they have, they may not have, but all over the discussions you will find, if they have a below 20, they must have a, both the habits, because they need some different types of food habits to cope up with their physical structure, or to grow their different because they are a developing state, okay, physical developing state, so they need every types of food habits. But if you are thinking more than 20 years, then we can very particular to our habits, right, food habits. So that shows in this particular matrix. I'm not telling my perception, I'm telling out of this particular matrix values, right? So this way you can derive the different kind, you n number of decisions, n number of what you call visuality you can have in this particular matrix form. So you can imagine, if normal data is there and if you are putting into the tabular format in a systematical manner, so it will be easy to predict something, it will be easy to take different types of decision, it will be easy to design different kinds of patterns, right? So that's why we are going for these methods and we are in these discussions. You can see multiple tables, right? So when we are going for multiple features or multiple dimensional, right? So you have gender, two boys and girls. In that, again we are dividing into, depends on, because these are the students. They may have a day scholar, that means they may not stay at the school or hostels, or they used to move, they used to come, or they used to travel, right, daily. So day scholar we have, and hostelers we have, those who are staying at schools hostels or college hostels, like this, right? So boys, in the boys category you will have two different, day scholar and hostelers. Then in girls also two categories we will have. Now we can have another dimensionality of over here, gender, boys and girls you will have two different. So now in this food habits also already we have a categorized data, right? Less than 20, greater than 20, greater than equal to 20, less than 20, greater than equal to 20. Now here what happens, constantly we are increasing different types of attributes or characteristics, but still it is looking, or the data visualization is very systematic. We don't have any confusion over here. Easily we can fetch, easily we can find out what type of value or which type of value you need, immediately you can fetch. That is the importance of matrix, right? So here you can find out the different types of informations based on different types of attributes, right? So this is the importance of matrix. Now you can understand what exactly the importance of, what are the different types of significance of matrix, okay, when we are representing different types of problems, or when we are representing data into matrix format. Now this type of situations we need or we require when we are going for data sciences especially, right? Because data sciences is a field where you can find out the different types of analytical things, different types of mining things, different types of pattern designing, right? So machine learning process, you will have a different kind of process you will have, and that time it is very important to know how to represent the data into different format. So this is one of them, right? Representing the problems here, the data, right? So problems with different matrix format. So I think this is clear. Next, you will have representing the problems with the relation. Now, we are not collecting only data. You might have come across the database management and the relational database management system. In that, you will find some extent we are extracting data and we have to maintain the relationship among them. Now, sometimes if you are extracting data or we are putting in a different format, if relations hampers or some kinds of relations they have at the initial state and they are having problems in the later stage, so that time it will be problem. So it will be a problem to access the data, it will be problem for mismatch the data sometimes, right? We cannot handle properly data because it is related. Now, for example, if I am telling employees table we have in database, if you are thinking about database concepts, right? We have employees table, we have a departments table. They have some link, and when we are extracting data into different format, right? So that time that same relationship should be maintained properly. So in our data mining concepts also, when we are extracting data through ETL tools, extract transport load, right? ETL tools. So that time the relation must be preserved, or relation must be maintained properly. So when you are representing data into dimensionality form, like we have a different types of schema in a data warehouse, like a star schema, so snowflake schema, then we have a fact constellation schema. So these three representations will help you to arrange your data which has been fetched from different OLTP labels, right? So now this data, the relations and all about the links must be preserved properly, so that it cannot have some problems in the later stage, right? So now we'll study how the relation, or how the relation is very significantly important for representing different kinds of problems. We can see here, we have given one simple example. Relation can be represented in many ways. We know relation can be maintained or represented in many ways. Some of which are as follows: relations as matrix, right? Let P, we are taking a matrix, right? P, we have different kinds of values. We have A1, A2, A3, dot, dot, AM, and Q, B1, B2, B3, Bn. So there are finite set. That means we don't have infinite value here, infinite members on this set. So now we have a finite sets, right? Containing m and n number of elements respectively, right? We have taken an example, right? So R is the relations from P to Q. Now, if you want to establish a relation, how to establish this relation? So you can see here, the relation R can be represented by M into N matrix, as I told in the beginning. So M into N matrix we can represent, and we can represent each and every value by using the matrix Mij. That's the positions you can define here. Now you can see here Mij. So one for I, one variable we can put, because we should have an increment of this. So Ij we have for both the set. So now the matrix Ij, that means positions of, you can have, if it is not belongs to, it is not related to the R relation. Now AI, this is one element, Bj, the another element, if they don't have a relate at all, they are not belongs to this R. That means this is not related to the relationship. That means we can put some zero value. This is one way to represent the relationship, right? You might have come across these examples in a relational algebra. Now, one, if there is exist a relation, so you can put R, that is AI and Bj belongs to R. If both the elements have some relationship, then you can put 1 on that. Now see in the right hand side, you can see this. So this is an example. This is, you have 1, 2, 3, one set we have, both the set we have, P and Q have. So now 1, 2, 3, then Q, A, B, C, D. Then the relationship we can mention here, 1 to A, right? Then 1 to B. Similarly, we have a different kinds of relation to C to D, right? So now how we can represent into the matrix format, you can see, right? So here you can have, that is one side you have a row, right? So 1, 2, 3, 4, we have a 4 elements of here P, and here you can have a Q, A, B, C, D. If relation exists, out of this you can find out 1A, there is a relation exists. So 1 to A, this matrix you can see 1 and A. So this is a matrix we have, and a relation we have belongs to R. So that is 1. Similar 1 to B, there is a relation is there. 1 to C, relation is there. 1 to D, there is no 1 to D. That's why it is 0. Similarly, 2 to A. 2A, there is a relation is there? No. So that's why 0. 2B, I think 2B is there. So it becomes 1. So by observing this, easily you can find out which data is related to which data, right? So which element is having some relationship with this. Now this particular matrix you might have find out when you will have a path determinations, right? As an we have a operations research you might have come across as you are MCA students. So now that time we have to find out different path, different designing the circuit, right? So that time we have to find out the different paths from one point to another point. So that time we can represent the whole matrix into a relational matrix we can have. So now we can represent where which path having how much weight for that you can mention here. So that time we represent also this way we can represent this. Clear? So now this is how data simply we are not converting the simply we are not represent into the matrix form, but rather we can have some relations, right? So you have to maintain that also when you are representing data into different format. So if there is a relations you have to preserve, you have to continue that relationship, right? There should not be any disturbances among the relationship among the elements, right? You can see the examples here. The same examples 1, 2, 3, that is P. P having 4 elements, Q having 4 elements, that is A, B, C, D. So we can establish different kinds of a relationship, that is R equal to 1, 2A, 2A, 3A, 1B, 4B. That's the same kind of example we have taken, and we can have a diagram over here, right? Arrow diagram relations R shows this. So 1 having 2 relations A and B, 2 having 1 relation, 3 having another 1 relation, and 4 having you can have a 3 relationship. 4 to B, 4 to C, 4 to D. Now this particular relationship can be represented into the matrix format, tabular format you can have here. So we can have a X, Y, Z in this column level, and 1, 2, 3 it's a row level. So now 1 to X cross you can give it cross. So cross indicates there is a relation, and if it is not cross, that is there is no relations at all. So this way also you can represent, right? So this is how we can continue the relationship if you have among the data. So we have to make this arrangement, right? We have to represent systematically so that there should be any problem in the relationship of the different kinds of data elements. And this is also very important for our features or data to features, right? Conversions, right? So when we are representing data into the features, or when we are moving from data to features level, this is very important. And when we are going for data sciences or data sciences process, so it is very important to make data into feature based, right? So now next we'll have computing simple statistics. Now you as per your syllabus is concerned, we have a different kinds of units. We have like statistics analysis, like mean, median, mode, variances, standard deviations, weighted average, right? Quartiles. So modes we have. So these are the discussions why we are going. You can go for other part of statistics also, advanced statistics also. But here the point is the role of statistics when we are going for different types of computing environment, or when we are moving to data analysis, or when we are going for data mining, data or design pattern, okay, machine learning. That time it is very important, and the statistics, the role of statistics is very important in this field, right? We have to see how it is. It is also here in this particular page you will find to convert the data into the features, or when we are moving from data to features based. So that time you can find out the importance of statistics also. It helps also a lot. See here we can discuss about, because I'll move in a faster manner, because you know as an MCA students you know what is these are the basic statistics concepts. So now in this particular concept you will find first is mean, right? So means arithmetic means to give the data in the sum of all observation divided by the number of observations you can have. This is a simple thing. So you have a number of, find the mean of the following distribution. You can have the example. Now this is the value x equal to 4, 6, 9, 10, and this is the frequency. How many times it is repeating, right? How many times it is occurrence, okay, or occurring. So now the occurrence of the elements, right? We have to find out in the frequencies, right? So now you have a x variable, we have a 4 value, how many times it is occurring? So 5 times. And the 6 value is occurring 10 times. 9 values occurring 10 times, 10 similarly 7 times, and 15 also similarly 8 times it is occurring. Now out of this, if you want to find out the mean, that means average value of this arithmetic mean, if you want to, you can see here simple logic, we have simple calculations. I have already put in the solutions also. It will be easy to memorize, or you can compare this. So now this is x1, we have a different kinds of values x1, so I can be increment, right? X values 4, x value 6, x value 9, x value 10. So frequency we have, what exactly we have these values, we are representing in this format, xi, fi, then we can calculate multiplication product of this xi, fi, right? So now if you will find xi, fi, we can ultimately finally we can calculate the summation of fi and xi, just sum of these values, summation of xi, fi. So now you make it 4 into 5 20, 6 into 10 60. These are the xi and fi, that is product of these two, okay? That is 4 is coming 5 times, that means 4 into 5 xi, fi will be 20. So now after getting this xi, fi, you make it a summation of all these values, you can add this. So now this is 360 you have. So now 360, and you can have a number of occurrence, that is frequencies 5, 10, 10, 7, 8. So that can be here 40. So number of occurrence you will be 40. So just divide it, you will find the mean of this. So 360 divided by 40 equal to 9. Thus the mean is 9. So this is a very simple example I have given for mean arithmetic mean, how to find out, right? Similarly, I have a second example. So you can have, this is a problem I can show you, and you can find out the mean of this. Just you check it. Here is an example where data is in the form of classes intervals. So you have a range of data, of a group of data, right? So 0 to 10, 10 to 20 range intervals you have. So now the following tables indicates the data on the number of patients visiting a hospital in a month. So we can find out number of patients 0 to 10. 0 to 10 means you have a range of data, right? How many frequency you can have? They are visiting 2 times you can have. So number of days visiting in a hospital. So 0 to 10 patients, they come twice in a suppose the number of days in the hospital. So 2 days you can find out. So here the following indicates the data number of patient visiting a hospital in a month. So it is a collections of data within a month we have collected. Now if you will see 10 to 20 patients, the 6 times they are coming within this 1 month. So similarly we can have, so 20 to 30 number of patients they are coming. So this is an example of a group of data, or we a range of data, or we have a interval class. So these are the groups or class we have. So number of we have, this is frequency you have. So you can also calculate this way mean, okay? So now you can see range of. So now here there's the same we have, and we have to calculate the mean of this. So mean of this you can calculate class marks xi. This is 0 to 10, and we have to make a class mark xi. We have to represent lower limit plus upper limit divided by 2. That means you have to find out the class mark. That means we cannot find out the range values, we cannot make a calculate, you have to find out the middle value, or we can have the average value of this, that is 0 plus 10 divided by 2, that is upper limit lower limit divided by 2, 10 divided by 10 plus 20 divided by this. So you will have this value. So 5 Here the point is when we have a number of examples, you can go for a number of example. I'm just giving for explaining the importance of here means is to convert into a different because we need mean values sometimes when we are predicting something, when we are making some decisions, that time we can find out this. Later on you will have the discussion why we are taking mean and we are calculating this, right? So now next we will have the part is your variance, right? So variance, it's also similar the important part of statistics, and for research purposes when we are going for researching or when we are making some different kinds of testing, hypothesis testings or some kind of testings, that time statistical techniques is very important. So variance is out of very important out of among all these, right? So now we can find out variance, right? So now what is variance we will go for, and you can have a different kinds of examples over here also. The variance is a measure of a variability. Variance means it varies, right? Variability. It calculates by taking the average of squared deviations from the mean. Now here the point is we have to find out the deviations. We can make it squared of the deviations, and we can find out this. So variance tells you the degree of spread in the data set, right? It gives you the degree of spread in your data set. So now we have a data set, we can find out the variance, how much it spreads into your data sets. It gives you the exact meaning to this. The more spread of data, the larger variance is in relations to the mean. So how much data is spreaded in your data set, you can find out, and the value depends on the value you can judge. So now when we are going for variance, you will have two kinds of variance here, populations and sample variance. Now what is population? As MCA students you might have come across, or I don't know. So when we are going for research methodology, right? Some extent in management people, they used to have that discussions, research methodology. Okay, so we have populations and a sample. We normally discuss about that when we are going for data collections. So the populations means the total data set, and sample means we out of which we have to take a few data which can be used for our research purposes, right? So we cannot take, for example, if I'll find or if I'll have some particular analysis on total populations of Indian populations, right? If I am doing some research on Indian populations, so I cannot collect data each and every people. I cannot meet each and every people. I cannot visit each and every people. So what I can do, I can use my sample technique. Sample technique. We have a different kinds of sample techniques. We have a random sample, stratified sample, then convenient sample, right? So we have a different kinds of a sample technique. So depends on different research, depends on the size of your populations, we use some kind of sampling techniques. Now by applying the sampling techniques, we can reduce the total populations, okay, into a smaller part. So that can be used for your research. Now, for example, if I'm analyzing a particular employee's performance in a particular organization, so employees, they are suppose 5,000 employees are working. So I cannot take data from 5,000 individually. So I can have some particular scientific or statistical method to make a convenient sample. Suppose I'll take 200 people's data, right? So how did you get this 200 people data? Depends on some scientific and statistical method, right? I'm telling that is the core part of your research methodology. I'm not going for deep on that discussions. So now you can have a particular scientific method where you can calculate minimum of out of total populations, minimum members you can take for your purposes, for your calculations, for your research purposes. So that we call sample, right? So this is brief about population and sample. So population is a vast area and sample is a few subset of this. So now sample is a subset of population. So you can consider this way. Different formulas are used for calculating the variance depending on whether you have a data from a whole populations or sample. So now here sometimes we can go for samples data or sometimes we can go for populations data. Now the variance which has been calculated based on the population, we call it population variance, and the variance which has been calculated based on the sample only, that we call sample variance. Now the point here is the variance in the population and the variance in the sample, right? There may be the little bit difference value. So you have to be very careful when we are calculating. You can see here the example in the right hand side. That is the sample variance. That is in the down you can have n minus 1. So n is sample size. Just will reduce 1. If you are going for population variance, that is capital N divided by this, so popular size. Now, for example, if you are going for our complete, we are taking a particular research on total people in the India or the world, or those who are vegetarian. So that time you can see a huge size, population size, but out of which if you are taking few elements like country wise, I am taking 1% people, right? So that time that will be a sample size. So when you are taking a sample variance, this would be the formula, and when we are going for populations variance, this would be the formula, right? So now you see here sample variance. When we collect data from a sample, the sample variance is used to make estimates or inferences about the population variance. Now, by taking inferences, by taking different kinds of values, okay, so we can predict either the sample variance or population variance. So when you are estimating the values based on the sample variance, so that time we can have different kinds of formula. That means we can have n minus 1, that is summations of n to I, that is equal to 1, summation xi minus x bar, that's formula you can use. So now this particular value, that is a sample variance value, infers you the total population. It tells about the total populations. It indicates the total populations, right? So now, if I am saying, see, by observing few animals, I am predicting the whole animal's characteristics. That's the point. Example. Populations variance, when you have a collected data from every number of populations that you are interested in, you can get an exact value of a population variance. Now, here the point is, I'm not eliminating anyone. I'm taking total elements of this. Now, for example, excuse me, if I'm taking only the people, those who are having more than suppose I can have those who are managers only. If managers positions we have in the organization, I'll take completely all the people. I cannot skip anyone. So that means the research area which encompasses, which specifies total elements, it should not skip, or it should not skip any particular elements, that we call population. And if you are applying the variance formula in populations, that indicates completely. Now here the point is, sample variance inferences to the population's variance, but population itself, it is a completeness, so we cannot have that type of inferences here. Yet it says always completeness, right? So this is how we have a distinctions between sample variance and population variance, right? Clear? This is an example, and this is a very small example. You can find out how to calculate the variances here, right? Let us understand the simple variance formula with the help of example. There are 45 students in a class. Imagine 45 number. This is very important. In a class, 5 students were randomly selected from its class, and their heights in inches cm were recorded as follows. So now here the total students is 45, but we are not taking the 45 students heights. We are taking randomly. That we call a random sampling, right? So we are taking randomly 5 students heights. Now you can see here in the right hand side, you can see here this table shows you 5 students height with respect to the inches, right? So 131 inches, 141. This is a 5 student randomly we have taken randomly. So sample size is 5. So this 5 can indicate whatever the value will have, whatever the calculated value will be there, that is sample mean, that can infer to the complete 45 students. So this is some extent there is a drawback limitations of this, but the statistics gives you sufficient, okay, approximately info to the complete populations. So that is the miracle of sample variance, right? So we cannot go for 45 students data. If you have a 45 student data, exactly you can have some conclusion, right? But without using 45 students data, only randomly we can have and we can predict something, right? You see here how we can calculate this sample mean, that is these are the values we have divided by 5. So this is exactly we find out mean, right? So values divided by number of occurrence 5, so 712 divided by 5, that is 142.4 cm. This is average value. Out of all these 5, we have taken the average value 142.4 cm. It's the average height of 5 students. Using this sample variance, we can apply to the complete here, the process here, right? So now using this, we can find out the sample variance formula, because this is only 5, not 45, only 5. We are working on only sample. So sample variance equal to summations of n to that is the range we have. So I equal to 1 to n. So xi minus mu square, that is we have a total 5, that is n equal to maximum value I from 1 to 5 xi minus this mu value means, that is mu means your average value 142.4 divided by this, and we can find out this value xi. So now here you can put the n minus 1. That means we have a sample of 5. We are taking 5 minus 1. Because for safer side we are reducing 1, because if you take 5 there may be chances of crossing the value. So we can take less than this. It will be more appropriate values, right? So now this is a calculated value. You can put these calculations. These are the calculations you have, and out of which you will find 66.3 cm square. Now this is your sample mean, okay? Sample mean previously it was answer of 142 cm, and sample variance is this is 60.6 this. So now this is how, sorry. So this is how we can compare here the sample variance, right? 66 in 3, that means 66.3 cm. It is an it varies. It varies in the samples. It varies in the samples. That means this value is spreaded over 5 these things. So we can find out this way how much value it is varies from one to another. So now 66.3 cm, it varies from one to another. That's a standard value we can find out. Got it? So now this is called sample variance. Next you will have population variance. Similarly, I have given. Now population variance means complete values you can take. There will be capital N. That's the formula you have. Now in this particular you can have a one case. Just will explain. And because of the time limit, you have to wind up in this particular session. Next time we will continue, right? So just to go through this, I'll just explain. Population variance. XYZ Limited, this is a company, is a small firm and consists of only 6 employees. So there are 6 employees in XYZ Limited, right? The CEO believes that there should not be high. This is one case. This is one situation problem. So CEO, that is founder, that there should not be high depreciations in the salaries of these employees. For this purposes, he wants you to calculate the variance of these salaries, right? Salaries of these employees are as under. Calculate the population's variance of these salaries of CEOs. Now these are the 6 employees we have and the salaries we have. You can see the value 1, 2, 3, 4, 5, 6, and we have an employee's name and they have a salaries in dollars. $30, $27, $20, $40. These are the salaries we have. Now there are total 6 observations. That means 6 employees. That means capital N is 6. This is complete data. There's 6 employees they are working and calculating the 6 values here, right? We are not skipping anything. We are not calculating only 2 or 3 like sample. We are calculating whole values here. Now 30, 27, these are the salaries divided by this. This average salaries we are calculating here, right? So $30. So average values we are getting 30. So the calculations of a population's variance, right? Here. Now you can find out sigma square, right? Sigma square can be done as follows. Sigma square equal to summation I equal to 0 to n, that is xi mu, that is mean, square divided by n, right? So here the only the difference is here we are finding the square of this and we are dividing here capital N. Capital N means a number of populations, right? Now you can see this is in the Excel format, right? It is calculated automatically. So you can see here easily. So now how did you get this? Now population variance 1, 2, 3, 4, 5, 6 employees name 30s. Now here you can find out mu. Mu means this value, average value. So you can find out this formula xi, that means x minus mu. So you can subtract these values from this. 30 can be subtracted from 30. This value can be subtracted. So x minus this is x value. So now you can subtract this mu value 30. Then 27 minus 30 minus 3. 20 minus 30 minus 10. 40 minus 30 10. So this way you are getting these values and you find out x minus mu, that is depends on xi minus mu square. So you can square it, that is a square value of this, right? So it becomes positive value. These are the negative values, it becomes positive values, right? So you can find out here the formula, right? So you can put to 214. So if you will calculate 214, so you will have. So now you can find out here the formula. You can use population variance, you can calculate from this. So now sigma square equal to 214 divided by 6. Now here the point is we have a n, capital N 6, and here we have a values of this, summation of this, right? Summation of this. So now after this 214 divided by 6. So now population variance equal to 35.6. Now the population variance of this salary is 35.67. That is your this particular value is spread over total complete 6 employees. So whatever the values we are finding, okay. So that is, see, if you are finding average and if you are finding the population variance, so how different it is. You can see here we cannot make any decisions on sometimes these things. Now this value is spreading to these populations completely 35.67. So as per the CEO decisions, he can take any decisions by observing this value. Now this is about population. Just I am giving in a brief manner because we have lots of things to cover this in this sections, right? I'm not taking all the examples, just I'm giving for a few examples. So you can have some other sources, you can collect the data from this and you can go through this. If you have doubts, you can discuss with us, and we have a discussion forum. So in that you can discuss and you can raise your questions and we will have a discussions, right? Thank you students. Thank you for your patience listening, and you can have a very good experience in data sciences, especially when we are working on different types of data analytical things, right? So thank you a lot.